Hello friends, welcome to Power Electronics. In the series of choppers, we are discussed the type A chopper, in which what we have got the result by the graph that it resides in the first quadrant. That V naught is positive as well as the load current I naught is also positive. That means the supply is flowing from source to load. Also in the type B chopper, where what we have got that voltage output voltage V naught is positive and the load current is negative. So that means that it is supplying from load to source. So with both their combinations, we have created a type C chopper in which we have connected these both choppers parallelly. And what we have got the result that V naught is positive, load current may be positive or negative, as you can see in the graph in the first and the second quadrant. Today we will discuss the type D chopper. As you can see in the diagram here, that it has two choppers CH1 and CH2 and two diodes with the load connected in between them. The first condition is here when the CH1 and CH2, that means both the choppers are on, then the output voltage is equal to the supply voltage. As I can simplify this diagram, you can see here if this is the chopper 1, this is CH1, in between the load is connected, and this one is CH2. So you can see that this is the supply voltage and V naught is the voltage across the load. So Vs equal to V naught when the both CH1 and CH2 are on. When both these are off, then what we got? We will get the V output equal to minus of supply voltage. So you can got this answer. So as we look how the supply works. When the both the choppers CH1 and CH2 are on, the current flows through this path, flowing through the chopper 1, then flowing through the load, and then it is flowing through the chopper 2, and then to the back path of the supply. So you can see the direction of the current in the load, it is drop plus minus, because in between the load may be inductor. So what you have seen that how it works. Now when both choppers are off, then this is are already charged, it changes, inductor changes polarity, because inductor does not allow sudden change of current. So it changes polarity and starts flowing through the diode D2, then to the back path and back supply and D2. So that means the diode D2 and D1 are conducting. So as we can see that in the positive group, V naught, here V naught and I naught both are positive. V naught and I naught, that is output voltage and the load current, are positive. You can see that in the first diagram we have made here. In the first diagram, the current flows through this chopper and then through the load and second chopper, then to the back path. You can see that here the I naught is same, so that means the I naught is in positive group. Also you can see that the output voltage is also positive. Output voltage is also positive. So both what we have seen the graph, it resides in the first quadrant. Now when both the choppers are off, in case both the choppers are off, then the current starts flowing to the diode D2, then to the back path, then the diode D1. You can see that here the load current is same as the supply current, because they are in the one direction as the marked polarity. So I naught here is again positive, but the supply voltage here is negative. As you can see that from the marked direction the supply voltage is negative. Also you can apply KVL to see that. So these are the two graphs we have obtained. First is in the first quadrant and in the fourth quadrant. So what we observe that for the positive, V naught and I naught both are positive, and in the last we have seen that V naught is negative and I naught is still positive. So you can also see by the graphs also. So how to calculate the average value of the V naught and I naught when it is positive? I will show you how the graph look like. So graph look like this. Here, if you observe here that there is a difference between both the graphs in the C and D. What is the difference in between them? The difference is here you can see that T on period. T on period is larger than here when the choppers are off. So you can see there is a difference in the time period. The T on period is larger, that means T on is greater than T off period. Here you can see that T on period is less than, or the T off period is greater than. But this, if T off is greater, that means here the voltage is also negative. So these are the difference you can observe. How to calculate their average value? I have already discussed that how to calculate the average value, that is area upon time period. How many time period it is conducting. Time period is the, you have to check the cycle from where it repeats again. Again this waveform repeats again. So this is the complete cycle. So the T time period. So you can see that up to this period it is conducting, then it is off. So how we can calculate this? So how we will calculate the average value V naught and I naught when it is positive. So you can see here V output is equal to the supply voltage Vs into the T on period, minus the supply into T off upon the complete time period. Same we can calculate for V naught and I naught for negative and positive. That means for the time period T off greater than T on. So here Vs equal to into T on minus T off upon the T time period. So what we have observed that average output V naught is positive when the chopper turns on time T naught is more than their turn off time. Direction of load current is always positive. So we have studied the three cases, that is T on is greater than T off. That means alpha duty cycle is greater than 0.5. So V naught is positive. When the T off is greater than T on, that is 0.5 is greater than alpha, then V naught is negative. When both are equal, then alpha is equal to 0. As you can also see in the graph available here, that T on period is larger and here the T on period is less than. So you can calculate here the average value also.